Convert the following expression to polar form. Okay, so we got z is equal to 5 plus 4i. What do we got here? Boom, boom. Okay, so here's I, here's real. 5 in the real, so there's 5, and 4, so not right there, but there in the imaginary. Okay, so here's our little vector, and we're going to call this the magnitude, and that'll be theta, always measured from the x-axis. Okay, always measured from the x-axis. So again, yeah, I'm going to use tan. I'm going to use tan to figure out this is distance. Let me write this down. So 5 is here, and this is 4. So I'm going to use tan. Tan of theta, yeah, is equal to opposite over adjacent. So opposite's 4 over 5. Okay, so now I'm going to take the tan inverse of both sides. So tan inverse of both sides, tan inverse of both sides, and I'm going to eliminate those things. So theta is equal to tan inverse of 4 over 5. Okay, so there's that one. And now we are going to do the r there. And for hex and giggles here, we're just going to use something else. Instead of using Pythagoras here, which could work, okay, r squared is equal to 5 squared plus 4 squared. So therefore, r is equal to square root of 5 squared plus 4 squared. Okay, I can use something else. Now, the reason why I don't want to use something else is because I already figured out this. So this already has some error to it. And then I'm going to use the error and then figure it out again. Like, come on, that's a sloppy. But I'm just going to show you to get the same way anyways. So I could use it by saying, let's do cosine. So cosine of theta is equal to, cosine is adjacent 5 over r. Okay, so r is equal to 5 divided by cosine of theta. Okay, so once I figured out theta here, I'll put it into there. And it's kind of like double error, you know. So this is why it's probably a better way to do it, because now these are actual values that are given to me into the problem, you know. So it's probably a more preferable way, but you can double error if you want it. So tan, that's why I always want to include more significant digits than needed. So tan inverse, bracket open, of 4 divided by 5, bracket closed, is equal to, now this is going to be in radians, 0.67, let's go 5. Okay, 675. See, I've already included some error. Okay, 6.47409242, and I've already included the error. Look how much I got cut off that. So let's check this thing out here. Let's put that in here. Well, I'm not going to put it in directly. So we'll put square root of bracket open 5 squared plus 4 squared bracket closed equals. So this is going to be 6.403. I'm going to include just some more here just to show you how much area you're actually going to get here. So now if I go 5 divided by cosine bracket open of this angle here, 0.675 bracket closed equals, I'm going to get 6.404. What? 455. Jeez, look at that. Look at that. It's garbage. Anyways, so that's why you probably want to use the original values, but you can do it any other way. No problem, right? So z is equal to, what is the value here? So I'm going to use the original. So 6.4, doesn't matter. We're going to use 6.4 anyways. E to the, what's the angle? 0.675 I. And that is in polar form.